So imaginary numbers, these are way different from what we know about real numbers. So this is under complex numbers, which can be divided into the types of numbers of real numbers. And we also have these imaginary numbers. The real numbers, these are like the rational numbers, and the irrational numbers can be further divided into the non-integers, the integers. These are going to be the natural, the zero, the negative integers. And under this chart is that in rational, there is also integers, whole, and natural numbers. All of those are under real numbers. Imaginary numbers, these are numbers that are built on the symbol of I. I is always equal to the square root of -1. So imaginary numbers is any number that can be written as a multiple of I. Okay, so this is different from real numbers because when we square any real number, it never gives a negative result. Like for example, squared plus 9 equals 0. When we think about this, we're going to transpose this, right? So x squared equals -9. Then we're going to be squaring this, and then we got -9. So we can't use 3 because 3 times 3 is 9. It's not -9. If we try 3 times 3, it's -9, but it's not the same negative. It has to be negative also in this side for it to become -9. So that's why we use this imaginary number for us to utilize them. So this one, this x squared equal this x plus 9. We're going to transpose this first, right? X squared equals -9. We're going to square root it, breaking this down. So this one, this is where the imaginary number comes from. We can multiply this by square root of -1. And then we're going to use this 9. And we know that square root of -1 is just equal to I. So this one just turns into I. And we know that square root of 9 is just 3. So when we write it, this is just 3I squared. We know from earlier that I is equal to the square root of -1. If we square I, we will get -1. If we cube this, we will get -I. If we 4 to the power of this, we will get 1. And what's amazing about these imaginary numbers is like it has a pattern that repeats. Like for example, if we have 5, square root of 5, we will have I6. It's just -1. I7 is -I, and then I8 is just 1. And then it repeats again. Wherein I9 is just I10 is -1, I11 is -I, and I12 is just 1. Like you see that these, once you broke down these parts, it just repeats by 4. Like you see this is I, and then it just repeats this part over here. But for operations of imaginary numbers, I just want you to remember that I squared is equal to -1. Okay, remember this. Okay, so when we're going to do operations on imaginary numbers, what's fun about this is it's just the same as adding polynomials together. So for example, this is 3 plus 2 times an imaginary number plus this other binomial. So we can think of it as 3 plus 2x plus 5 minus x. The same principle as how we're going to add polynomials. So in adding polynomials, we add the like terms together, right? So this one, 3 plus 5, that's 8. And then like term is 2, -1, that is just 1. And then we're going to copy the variable, or we're making the I as a variable. So our answer is just a plus 1I, or simply just 8 plus I. So this is our answer for 8 plus I. So this one, we're going to subtract the like terms. This is subtraction, okay? Subtract. We're going to subtract the like terms. So 6 minus 4, that is just 2. And then we're going to subtract -7 minus -11. which is just 4, and then copy the I. And our answer is 2 plus 4i. To elaborate on that, it became plus 4 because we added minus 7 minus negative 11. And that just becomes negative 7 plus 11, which becomes 4. Okay, so that's why we got this. Multiplication and division, this is just the same as foiling binomials, wherein the F is the first term, O is the outside term, I is the inside term, and L is the last term. But the only twist is when you get an I squared, you're going to substitute that with negative 1. Okay? So for example here, when we're going to FOIL, we're going to multiply the first terms together. So this one, 9 times 2, that is just 18. And then outside term, 9 times 2i, that is just 18i. And then inside term, negative I, 2i. And then the last term together, which is just 2i squared. Now, we can further simplify this one. So we can see that this is our exponent here. And in PEMDAS, we start with the exponent first. So I squared, again, is just negative 1, 2. And then this will just be negative 1. And when we multiply negative numbers together, that just becomes positive 2. And then let's just rewrite the whole thing again. 18 plus 18i minus 2i plus 2. Then we can just add the like terms together. So these two, 18i and 2i, that's just 16i. And then this two, 18 and 2, that is just 20. So our answer is 20 plus 16i. The next one is division. This is a bit more tasky because in division, we want to have like a number on the denominator or like something that's easier to deal with. So what you can do is you look at your denominator. We have 4 minus I, right? We can actually multiply this by the conjugate of 4 plus I, 4 plus I. If this were a plus, you will be having a conjugate of 4 minus I. But since it's not, it's a minus sign. We're going to do plus I. Now, we can actually rewrite this as a binomial of 6 plus 4i, 4 plus I, 4 minus I, 4 plus I, which is basically just the foiling method or the multiplication again. So let's start with the numerator here. So our numerator is 6 plus 4i and 4 plus I. That is just the first term, 6 times 4, that's 24. The outside term, 6 times I, that's just 6i. The inside term, 4i times 4, that's 16i. And then the last term, 4 times I, that's just 4i squared. And then we can simplify this. We know again that if we have an I squared, that's just going to turn into negative 1. So when we multiply negative 1 with 4, that's just going to become negative 4, right? And then we're going to rewrite this whole thing. Then we can add the like terms. That's 24 plus 22i minus 4. That's just going to become 20 plus 22i. It's going to be our numerator. Now let's do the denominator. Let's write that the difference of two squares, which is a squared plus b squared, right? So that's just 16 minus I squared. So that will become negative 1, and this whole thing will turn into 17. But you can also do the FOIL method for this. If you do the FOIL method again, so 4 times 4, that's 16. Outside terms, 4, that's 4i. Inside terms, that's negative 4i. And then last terms, that's just I squared. Then these two will be canceling out, and we'll be left with 16 minus I squared, negative 1. which will become 6 plus 1, which will become 17. Our numerator is 20 plus 22i, and our denominator is 17. And we can use this standard form, which is a plus bi, wherein the a is the real number and this part is the imaginary, which creates the complex number that we know. So this can be halved together, or like this can turn into 20 over 17. And then this 22 times I and 17, that can turn into 22 over 17 I. And that will become our answer.